Hey guys! Today we're going to focus on measurements and conversions. There are 7 different base units in the metric system, but we are only going to focus on 3 of them in this class. The first one is meters, which measures distance. The second one is grams, which measures mass. And the third one is seconds, which measures time. Now, in addition to these base units, we are going to add prefixes to them, because even though grams is the base unit for mass, it's unlikely that we're going to measure a car in grams because that number would be very, very high. A gram is approximately the size of 1 paperclip. So a car would be millions upon millions of paperclips. So instead, we're going to use the prefix kilo or kilo along with grams in order to create a variant of that unit that depicts a much larger number. So we're going to look at those prefixes, we're going to look at converting, we are also going to look at converting between different units such as miles to meters or kilograms to pounds. Okay, but first we're going to focus within the metric system only. So meters, grams, and seconds are the measurements that we're going to be using. I have listed on the right is a stair step. What this is a simplified way of converting through the metric system. So on the stair step we have a total of 7 stairs. The top stair is kilo, which has a prefix of a K. The second stair is hecto, which is a prefix of an H. Deca, which is a D, A. The base unit, which is just the normal unit of measurement, so this is where grams, meters, and seconds go. Deci, which is just a little lowercase d. Centi, and milli. When I write my stair steps, or when I draw my stair steps on the board, I tend to do this. And I have a K with a line, an H with a line, a DA, a base, a D, C, and an M. This is a reminder that you place that base unit, so that grams, or that meters, or that seconds, on that line. So up here we would have kilometers. The base unit would just be plain meters, and the bottom would be millimeters. So that's how I'm going to draw it on the board when we work through these problems in class. But this visual to the right is really good to give us an idea of how this works. So each prefix is 10 times larger or smaller than the prefix next to it. So 10 jumps to 100, jumps to 1,000. They're a difference of a multiple of 10. So in order to use this to convert, we need to remember what our individual prefixes are. So we have a K, an H, a DA, the plain unit, deci, centi, and milli. And I'm going to add my little lines next to them. And for this first problem, I'm going to work through with green. We want to convert 57 grams to kilograms. So grams goes here on the base unit, so it's just regular G. And we want to go all the way up to kilograms, which would be kg. So if we start at this step, we jump 1, 2, 3 places to the left. Okay? So 57 has a decimal right here, even though it's not written. And when we convert, we're going to jump that decimal the same number of places that we jump here. So 1, 2, 3, this becomes 0.057 kgs. So on this line, I'm going to write 0.057. The next one, I'm going to work through in blue. So we're going from hectometers all the way down to millimeters. So underneath, I'm going to write M at the base unit level. This would be HM, or hectometers, and this would be MM, or millimeters. This is always the most confusing step, because a lot of people jump here for regular meters because there's an M located there. But remember, that M is the prefix, not the base unit. So we're going to start at hecto, and we're going to jump 1, 2, 3, 4, 5 steps to the right. So 207, our decimal's right there. We're going to jump 1, 2, 3, 4, 5 steps to the right. That is actually 207 and 5 zeros after it. Then I'm going to go back in and add my commas to show the placeholders. Now this line's a little small, so I'm going to write it next to it. 207 hectometers is 20,700,000 millimeters. Now we can do the same types of problems within the metric system using something called dimensional analysis. But dimensional analysis can be used in multiple different ways. We can go meters to centimeters, centimeters to kilometers, but we can also go kilometers to miles or pounds to grams. So this can get us from the English system into the metric system to use in the science classroom. Dimensional analysis, we use a series of fraction bars to help us convert. When we set up these fraction bars, we are using individual conversion factors to get from one place to the next, and we may have to use multiple fraction bars to do multiple conversions in one. Dimensional analysis is very, very useful because you can do very complex conversions in one big long step instead of doing 5 or 6 smaller conversions at once. So we're going to look at the same examples so we can compare them to the answers that we already had. So 57 grams to kilograms. The number that I give you always goes on the first fraction bar over 1. And we're going to put a little multiplication sign in the middle and draw a second fraction bar. So the whole idea behind dimensional analysis is to get one unit to go away completely and to keep the other one around. Since grams is on the top of this fraction bar, in order for it to go away completely, I need to place it on the bottom of the next fraction bar, because when we multiply them, they're going to end up canceling. So I'm going to put kgs on the top. Now I'm going to write my stair step over here because I'm going to teach you something useful with it. I have kilo, hecto, deca, base, deci, centi, milli. So what is bigger, 1 kilogram or 1 gram? Looking at the stair step, the bigger item's always closer to the top. So kilogram is bigger. So I'm going to put a 1 there because I don't like using decimals when it comes to math. I'd rather use whole numbers. But I don't remember how many grams are in 1 kilogram. So what I'm going to do is put a 1 on the kilogram line, and I'm going to fill in zeros until I end on the baseline, because that's where gram lives. So 1 kilogram is 1,000 base units. So 1, 1, 2, 3. Now multiply across the top. 57 grams times 1 kilogram. Multiply across the bottom. 1 times 1,000 grams. Now we're going to cancel out. There's a gram on the top and a gram on the bottom, so those go away. We are left with 57 kilograms over 1,000, and our last step is just simplifying this fraction. So we have found out that 57 grams is actually 0.057 kilograms. Now that should be the same answer that we had on the previous slide. So we can do that by jumping the decimal 3 places to the left, but we can also do that using the dimensional analysis. Okay, so the next one I'm going to do in green. We have 207 hectometers to regular millimeters. So 207 goes over 1 because the first number that is given always goes on the top of the first fraction bar with a 1 beneath it. Our second fraction bar, we are going to go from HMs to MMs. So since hectometers is on the top here, and we want hectometers to go away, we're going to place hectometers on the bottom. That means millimeters is going to be placed on the top because we want to keep that around. So look over at our stair step. Which one is closer to the top of the stair step? Hectometer. So I'm going to put a 1 in front of hectometer. And a hectometer has 1, 0, 0, 0, 0, 0. So 100,000 millimeters. So 1 with 5 zeros behind it. 1, 2, 3, 4, 5. Okay. Now multiply across the top, multiply across the bottom. We have 207 HMs times 100,000 millimeters over 1 times 1 hectometer. So now Hectometers can cancel because it's on both sides of the fraction bar. And then we have 207, 1, 2, 3, 4, 5 millimeters over 1, which is just 20,700,000 millimeters. So that's our final answer. And that, again, is just like it was on the last slide. It was just a different way of solving the same problem. So what we're going to look at in class is practice between converting within the metric system, like we did here, where you can check your work with the stair-step method, and then we're going to practice converting across metric to English.